Welcome once again to a futures video. I'd like to speak with you tonight about the second reason for hedges performing less well than we might hope they would. So we talked in the last video about the two primary causes of poor hedging performance. The first one was basis risk, and we talked about that in the last video. And the second reason is instability of the hedge ratio. So let's look at that now and see some of the issues that relate there. So number two, instability of the hedge ratio. Now you remember that the optimal number of futures contracts to take a position in was equal to the size of the cash asset, the size of the cash position divided by the standardized size of a futures contract, okay, multiplied by the hedge ratio, okay? So the optimal hedge ratio here gives us the optimal number of futures contracts to take a position in to hedge, okay? So again, this value right here, just to make sure you're up on this. This value right here is the size of the cash position. This value right here is the standardized size of the futures contract. Alrighty. So now the hedge ratio can be estimated by performing regression analysis, as we just talked about earlier in an earlier video. And let's now look at what's up with an unstable instable or unstable hedge ratio. Okay, historically, airlines would hedge the costs of their jet fuel, and because historically there were no futures with jet fuel as the underlying asset, they used to use heating oil futures because heating oil futures were most positively correlated with the behavior of the spot price of jet fuel, better than gasoline futures, better than crude oil futures. So heating oil futures were used, okay? And let's kind of look at that for a second. Let's assume that we're regressing the change in jet fuel spot assets. So change in jet cash equals beta naught plus beta 1 times the change in heating oil futures plus the error term. Okay? And let's say when we're done with this, and by the way, let's assume that we have monthly data, for example. And when we're done with this, the regression package will spit out a value for beta 1. And let's just say the beta 1 value is 0.66. Okay? And again, we had data for January and February and March and April and all the months of the year, and simultaneous observations of jet cash and heating oil futures prices. And this was the beta we got, okay? So in this case, assume an oil distributor plans to maintain a 4.2 million gallon jet fuel inventory, okay? 4.2 million gallon jet fuel inventory. For the first several months of this year, if this hedge ratio of 0.66 is used, then the oil distributor can sell. Remember, he owns the jet fuel in this example, so his downside risk is associated with the market price of the jet fuel falling. So in order to hedge the value of this, assuming we want to stick with this 0.66, the first month he will, let's say the first month is January, he will go, he will sell 66 February heating oil futures contracts. Okay, he'll do that in January. Okay, because remember the February contracts stopped trading late in January. So he'll sell 66 February heating oil futures contracts in January. And then on the last trading day for the February contract, he will roll these 66 February contracts into 66 March contracts. So what he'll do then is he'll buy or take a long position in 66 February heating oil futures contracts, and he will sell 66 March heating oil futures contracts. Okay, and if you can see what's going on here, what he's really going to be doing is when he buys the 66 February, recognizing that he's previously sold 66 February, that effectively cancels. It's like he's closing his position. I've already mentioned it. What he's really doing is he's obligated to both make delivery and take delivery of the number of gallons associated with 66 contracts. Okay, so he would do this, and then when he sells the 66 March contracts, then he's effectively rolled his January hedge into a February hedge. So these March contracts will hedge the value of the inventory in February. Okay, and and to hedge the March, you can imagine he would buy 66 March heating oil futures contracts and sell 66 April heating oil futures contracts to hedge the March, or to hedge the value of that inventory for the month of March up to the last trading day in the up to the last trading day of the April heating oil futures contract in late March. Okay, so that's how that works. But what if the yearly beta, this is a big question. What if the yearly beta, so I just write, what if yearly beta 1 was different than monthly beta 1s, right? Plural there with the S. So here the idea is maybe for the month of January, the distributor should, to hedge January values, maybe he should just use historical data that dealt with the relationship between heating oil futures and the spot price of jet fuel in the month of January, historically. And then he'd get a hedge ratio estimate from that regression. And maybe that 1 month beta, the January beta estimate, maybe that 1 month beta using just January data would be different than the 66 value we had come up with when we had annual data and calculated an annual beta. And then the idea here is that if you then, let's just say you take a position in 68. Let's say he sells 68 excuse me, heating oil futures contracts February contracts to hedge January's values, okay? And then maybe to hedge the next month's values, well, he's going to have to, buy 68 February heating oil futures contracts. So he effectively closes that out. But maybe when he ran the regression using February data, February jet fuel spot prices and February values for the March heating oil futures contracts historically. Maybe when he ran that, simultaneous observations of those, the beta estimate maybe was, let's just say, 0.72. Okay? Well, if it's 0.72, keeping in mind that the standardized size of a heating oil futures contract is 42,000 gallons, right? And he's got an inventory just of 4.2 million gallons, right? So that's 100 times. So he has to do 100 contracts. Well, he has 100 times the 42,000, and but the beta's estimate is not 1, so he's going to take the 100 and multiply by the 0.72, and thereby get 72 contracts. So here he's closed his hedge using February contracts for January, and then the next thing he would do associated with that would be he would sell 72 March heating oil futures contracts, and that would work to hedge the value of that inventory in the month of February, and so on. So the idea here is that if your yearly beta differs from monthly betas, you may be better served by using your monthly betas. You'll get better hedging results, and where the rubber hits the road, we see that you will be taking a short position in a different number of contracts every month, most likely. And that's the idea of an unstable hedge ratio. And so I guess that's enough for that topic. Now, one more thing I'd like to talk about here. And that is the idea of output uncertainty. So this is kind of a different topic, but output uncertainty. Well, the idea here again is, well, hedgers use futures contracts to reduce or control price risk. But as I mentioned in my first futures video, quantity risk is a big deal. We talked about a farmer who had, wanted to lock in a selling price of wheat, and then we looked at a circumstance where there's flooding or drought, and where the size of his actual harvest differs from his expected harvest. So that's output uncertainty. And the way farmers deal with output uncertainty is to consider, well, maybe don't hedge. So, one possibility is maybe do not hedge. Just don't do it. Okay? Because you could end up with a speculative futures position, as we talked about earlier. Okay? A second possibility is to adjust the hedge ratios. Adjust the hedge ratios. Maybe, maybe under hedge. Because when you under hedge, you're still on the hedging efficiency frontier. The opposite is true. If you over hedge, you would not be on the hedging efficiency frontier. And in agriculture, they might hedge from 50% to maybe 67% of expected output, okay, expected harvest. And so that's another way of dealing with output uncertainty. It's a big deal. Output uncertainty is a big deal. And one thing I'd like to mention again is that, or for your consideration, is that if a firm is using silver bullion in a production process, it's rather easy for them to hedge the value of the silver inventory if they choose to do that. Okay? But if you're a farmer and you are planting wheat seed and hoping to harvest a lot of wheat, one important thing to remember is that wheat seed does not equal harvested wheat. In other words, we speak of farmers as if they're hedgers, and they are, but it's hedging in the context of output uncertainty. And that makes it more challenging than it is for, users of industrial metals and their futures contracts if they choose to hedge values. And one other thing I'd like to mention is that we'd earlier talked about a measure of expected hedging effectiveness. We can also look after the fact and see how well our hedges perform. And there's an after the fact, an ex post measure of hedge effectiveness. And that ex post measure looks like this. 1 minus the variance of the profits of the hedged position, and divide that variance by the variance of the profits of spot asset only position. Okay, so you divide that. Now, again, you would expect the variance of the profits of the hedged position here to be a lot lower than the variance of the profits of the spot asset only position here. And so this, we'd have 1 minus a number that was ideally very small. 1 minus a very small number. And therefore, we'll say the closer to 1, the more successful. Erase that. The more successful the hedge. Closer to 1, the more successful the hedge. And closer to 1 what? This ratio right here. It's an after the fact, an ex post measure of hedge effectiveness. And that will be all for this video. Thank you for watching.